Howdy AGP students, this is your SAT Math instructor Chris. This session will cover applying strategies for Gridin problems. When completing the Gridin section, be sure to fill in the ovals and the boxes across the top. You want to make sure that your answer choices are counted. Remember, if the answer exceeds the number of spaces available, your answer is definitely wrong. With the Gridin section, there's no penalty for wrong answers. That being said, do not waste your time trying to figure out a problem if you get stuck. Utilize your target score strategy to manage your time appropriately. When you answer the Gridin problems, make sure not to leave your answer as a mixed number. If you do this, the computer will give you the wrong answer. For instance, if your answer is 4.5 and you try to write it as 4 and 1 over 2, the SAT will actually register this as 41 over 2, which is a much different answer. So make sure that you don't keep any mixed numbers and you change them all to improper fractions. Also make sure that you're entering your answer in the correct format. If the answer calls for a percentage, don't answer in a decimal point. Answer in a percentage form. Or if the answer is in dollars and cents, make sure you use the decimal point in the appropriate place. This is very important to help you succeed on the SAT in the Gridin section. The trial and error method can be used for the Gridin section. You can utilize this strategy when there are no algebraic equations, but the problem can be solved the same way as a solve for x problem. Remember, if you're given some information and asked to find some other thing, this is a prime opportunity to use the trial and error strategy. Let's take a look at a couple of examples. Trial and error example 1 states, you have only dimes and quarters in your pocket, and there are 4 more dimes than quarters. If the total value of the coins is $3.55, how many quarters do you have? This problem is giving us some information, and we need to find how many quarters we have. That's what the question is really asking us. And the other piece of information that we have is that we have 4 more dimes than we have quarters. So in this case, we can just take some guesses at how many quarters we have and then figure out if that's the correct answer. So let's start with 8 quarters. So if we have 8 quarters, that means we have 12 dimes. And so we can set up a real simple arithmetic problem and find out if this is the correct expression. So we have 8 times 25 cents if we have 8 quarters plus 12 times 10 cents. And does that equal $3.55? Let's check it out. So we multiply 8 times 0.25 plus 12 times 10.10, and that equals $3.20. So I think it's safe to say that $3.20 does not equal $3.55. And now we can do the same kind of strategy that we use with the trial and error. Do we need to go up or do we need to go down? So if we increase the number of quarters, that's going to increase our overall sum. And so that's what we need to do here because we're actually less than $3.55. But we're pretty close, so let's go ahead and try 9 quarters. So if we have 9 quarters and 13 dimes, we can work out the problem in the similar way. Here with our calculator, we can multiply 9 times 0.25 plus 13 times 0.10. And that's going to give us $3.55. So just like that, with guessing and plugging our guesses into the information that we have, we solved this problem pretty rapidly, and we got the answer of 9 quarters. So you can write that on your Gridin section and grid in the oval and move on to the next section. So now we'll look at example question number 2. Example question number 2 reads, a rectangle's length is 3 times as long as its width. If the area of the rectangle is 48, what is the perimeter? This problem, we're given some information and we're trying to find something. That thing is the perimeter. And we're given the area of the rectangle, which is 48, but we're also given another piece of information, that the length of the rectangle is 3 times as long as its width. So this is where we can actually make up some numbers and make sure they meet the constraints of the length being 3 times the width, and then we can find out if that area does equal 48, and once we solve that we can then find the perimeter. So with this problem we'll go ahead and start with a width of 5. If we have a width of 5 and the length is 3 times the width, our length is going to be 15. And so let's go ahead and check that, and 5 times 3 sure is 15. And so now we'll move on and we'll find the area of the rectangle that we've created. So we'll put in this expression, we'll do our math, 5 times 15, and we'll find that the area of this rectangle that we've constructed is 75, which is actually greater than the area that we're given. So we know that we need to reduce our width and length so that we can reduce the area, and then we can solve for the perimeter. So let's go ahead and reduce it by 1, and we'll go with a width of 4. With a width of 4, that should give us a length of 12, because 4 times 3 does indeed equal 12. With this, we'll go ahead and use our area formula again, and if you forget this formula, you should memorize formulas like these, but if you do forget it, it is on the first page of the section on the SAT exam. So here we'll set up this expression, 48 equals 4 times 12. We'll get out our nice calculator, we'll multiply this out, and we'll see what we get. And sure enough, 4 times 12 does equal 48. And that gives us the length and the width of this rectangle as 4 and 12. But that's not what the question's asking. The question wants to know what is the perimeter. So in order to find the perimeter, we need to add up all the sides. And because this is a rectangle, we have 2 sides that are the width and 2 sides that are the length. Here, so we add all 4 sides and we get 4 plus 4 plus 12 plus 12. And that's going to give, let's calculate that real quick. 4 plus 4 plus 12 plus 12. And that equals 32. So sure enough, our perimeter for this is 32. And just by taking a guess, making up some numbers, and making sure they fit the constraints, we solve this Gridin without much work at all. Now that we've looked at applying trial and error to the Gridins, let's explore using the backdoor play. The really nice thing about using the backdoor for Gridins is we never have to do the third step, because there are no answer choices. We simply grid in the answer that we get. We'll apply the same procedure as before, making up numbers that fit the constraints of the problems while avoiding 0, 1, or 2, or if we're dealing with angles, 30 degrees, 45 degrees, or 60 degrees. And then we'll plug that number into the problem and get an answer. And then we'll grid that answer into the answer sheet. And remember to bubble in those ovals. Now let's look at our first example. Example 1 states, the average of x and y is twice as large as the average of A, B, and C. What is the value of x plus y divided by A plus B plus C? Now this may seem kind of tricky, but we can make up some numbers and go from there. So we know that we're looking for the value of x plus y divided by A plus B plus C. And we know that the average of x and y is twice as large as the average of A, B, and C. So let's start there, and that's where we can begin to make up our numbers. If we use an average of 40 for x and y, we can pick 2 numbers that will average up to 40. And so here you see I've chosen 38 and 42. And this is kind of a trick that you can use anytime that you're looking for an average of a number. Pick the average that you want, and then pick 2 numbers that are equally distanced from that number. In this case, 38 and 42 are both 2 places away from 40. But we'll go ahead and do the math just to check it out and make sure we have the right numbers. So we'll add 38 plus 42, and that's going to give us 80. We divide that by 2, and now we have an average of 40. So the average of 38 and 42 is 40. Now that we have that average of x and y at 40, we know that this is twice as large as the average of A, B, and C. So the average of A, B, and C needs to be half of 40. So if we divide 40 by 2, that's 20. And so let's pick some numbers that are going to average to 20 for A, B, and C. So here you can see I've chosen A to equal 18, B to equal 20, and C to equal 22. The same logic applies as before. Here we have three numbers. One of them is actually the average, which makes it kind of nice. And then we have two numbers that are equal distance from the average. So we'll go ahead and check the math and make sure we have the right numbers here. So we'll add 18 plus 20 plus 22, and that equals 60. We'll divide that by 3, and sure enough, our average is 20. And so now that we have some numbers here, we've made them up, we've picked them, they fit the constraints of the problem. Now we can plug them into the equation that we have here. So when we plug this in, we have x plus y divided by a plus b plus c. Now we can plug in our variables and solve this problem. So we have 38 plus 42, and that equals 80. And then we have 18 plus 20 plus 22, and that equals 60. So now we have 80 divided by 60, and we can reduce this fraction. So let's see, 80 divided by 10, that's going to give us 8, and then 60 divided by 10 gives us 6. So this can be further reduced if we divide both 8 and 6 by 2. So we'll divide 8 by 2, and that gives us 4, and 6 divided by 2, that gives us 3. So that fraction is reduced all the way, and it is 4 over 3. So now we can grid in 4 over 3 on our answer sheet and move on to the next problem. Our next example is example problem 2. In this example, the problem states, if 4x equals y, what is y minus x? So if we look at this picture, we have a triangle, and it's a special triangle because it's a right triangle, and we can tell that because of the nice right triangle symbol here in the corner. That means that that angle is 90 degrees. The x and y angles are indicated here, and we have some constraints in the problem. 4 times x has to equal y. So now we need to make up some numbers that will satisfy this requirement. So nothing comes to mind right offhand, so let's look at 20 maybe. Let's see if 20 will work. So if we have 20 for x, and y would be 90 minus 20, which equals 70. So we have 20 and 70. Now let's see if that fits the constraints of our problem. We have 70, which is y, equals 4 times x, or 4 times 20. So if we multiply 4 times 20, we're going to get 80, which indeed does not equal 70. So we know that that is not correct. However, we know which way we need to go. Because our result was greater than what we needed, we need to reduce our x value. So we can do that. Let's go down to 15 and see what happens. So if we put in 15, we'll go ahead and calculate that. So 75 equals 4 times 15. And that's not true because it actually equals 60. So we know that we're actually too low now, and we need to actually increase our value of x. And so since our first guess was 20 and this one was 15, let's go somewhere in between there. Let's try 18, say. And so now we have 18, and we can calculate what the y value would be there. And so we can take 90 minus 18, and that's going to be 72. And now we can plug that into our formula for the constraint, and we can look at 4 times 18, and sure enough it does equal 72. So now we know that x and y are 18 and 72 respectively. But that's not what this question's asking. It actually wants to know what is y minus x. So now we simply plug 18 and 72 into the equation of y minus x, and we can calculate that really quickly by just subtracting 18 from 72. and that gives us 54. So this problem, the answer is 54. In this lesson, we covered how to implement trial and error and the backdoor play when working grid-in problems. We'll work through more of these problems in class so that you become really comfortable with these methods and can recognize them right away.